Good afternoon, class. We are looking at the final exam review covering all modules from module 1 to 4, trigonometric functions, identities, equations, applications, periodic functions, polar coordinates, and vectors. Everything from A to Z. So here's an example we've seen before. Two boats that are leaving the harbor in different directions. They make an angle of 135 degrees. One boat travels 300 feet and the second one 350 feet. How far are these boats apart? Draw a diagram. So one is going this way, one is going that way. They make, so we're going to call them ABC. They make a 135 degrees angle in between, and one of them is going about 300 feet, the other one is 350 feet. Okay, so that's the setup. So the question is how, what is the distance BC? We call it A. So we're going to use the cosine law. According to cosine law, A squared is B squared plus C squared minus 2BC cosine A. So therefore, A squared is this side squared plus this side squared plus 2 times the product of the 2 times cosine of 135 degrees. And basically, you plug it into a calculator. You square this one, you square this one, and this one is the same as cosine of 45 degrees, however, negative in the second quadrant. You put it into a calculator, you come up with A squared, you take a root, and A becomes about 600.83, close to 601 feet. Okay. A rocket takes off at a bearing of north, 30 degrees east. After flying for 900 meters, the pilot turns 90 degrees and heads northwest. After flying for 1,000 meters, what is the new bearing of the plane? Draw a diagram. First and foremost, let's remind everybody that one type of bearing deals with north-south, and we look at the closest angle to it. From the right side would be east, from the left side would be west. For example, this point, it's north, 30 degrees east. This point would be north, 70 degrees west. This point would be south. We either go with north or south, the closest angle. And the angle is an acute angle. It's somewhere between 0 and 90 degrees. So south 50 degrees and on the left is west. If we want to go with this one, south comes first, 20 degrees, and on the right side, it's east, just as an example. So for this case, we are looking at north 30 degrees east. So first, the concept of a bearing I wanted to explain. Now, in this direction, it goes for about 900 meters. Then there's a 90 degree. 90 degree, you can go up or down. So 90-degree angle. So heads northwest. So it goes this way. So 900 meters going this way. 1,000 meters. So now this one, we want to find the new bearing. So first and foremost, we are interested in calculating this angle, we call it alpha. And when we find it, it's going to be northwest, in between is the angle alpha. So how do we find that? Notice this angle, we can find it. We're going to call it theta. And this angle is 30 degrees. So this is 30 degrees. So if we find theta, theta minus 30 will do the job for us. That's the bottom line. And so if you look at this triangle, okay, this angle theta, tan of theta is the opposite 1,000 over the adjacent 900. So, or you drop 2 zeros, 10 over 9, which makes theta tan inverse of 10 over 9. And you put that into a calculator, tan inverse of 10 over 9, and 48.01 degrees. Subtract 30 degrees from it, 18.01. And the answer is north, 18.01 degrees west. That's the final answer, everybody. Plot the points first, then find their coordinates, find the Cartesian rectangular coordinate 6, comma 1, 50. So again, it's important to know when you want to come up with we want to plot the point in polar, you start, it's r comma theta, and you start with theta. So you go 150 degrees. As you can see, this is 105, 120, 135, 150, and that's the line you need. And you go how many tick marks? 6. Because we are dealing with circles, concentric circles, we count 1, 2, 3, 4, 5, 6. The sixth one is right here. That's how you come up with the answer. Now, to find the Cartesian, reminding everybody that polar is r comma theta, rectangular is x comma y, and x is r cosine theta, y is r sine theta. So let's go with x equals r cosine theta, cosine of 150. And I'm going to remind you, 180 minus that, the reference arc is 30 degrees, which means is the same as cosine of 30 degrees. However, in the second quadrant is negative, so minus square root of 3 over 2. And it's negative 3 square root of 3. For the sine, okay, y equals r sine theta. Sine of 30 degrees is 1/2. In the second quadrant, sine is positive, so 6 times positive 1/2 is 3, and therefore these two are equivalent. What about the polar coordinates for this rectangular form 2 comma negative 2? Reminding you again that this goes 2 to the right, 2 down, as far as location is concerned. Rectangular, x squared plus y squared must be r squared, tan theta is y over x, and you have to decide as far as the quadrant and therefore adjust it accordingly. So the very first thing we have to do, x squared plus y squared, that means 2 squared plus negative 2 quantity squared, and as you can see, it's 8 and 4 and 4 is 8, and r is 2 squared of 2 because square root of 8 is 4 times 2. 4 comes out as 2, and 2 remains. And tan theta is y over x. So it's negative 2 over 2, which results in negative pi over 4. So we found r to be 2 square root of 2. We found theta to be negative pi over 4. Therefore, the pair 2 comma negative 2 is equivalent to 2 square root of 2 minus pi over 4. If you want to go with a positive angle, the first, revolution, all you have to do just add 2 pi, and 2 pi with negative pi over 4, they add up to 7 pi over 4 in case. Let me erase my work so you can see that. So add 2 pi if need be. Transform the polar equation r equals 2 cosine theta to an equation of a rectangular coordinate system. So when we have r and either sine or cosine is involved, we know that x represents r cosine theta, r squared is x squared plus y squared, and r in this case is 2 cosine theta. The technique is to multiply both sides by r. So that gives you r squared, and the right side is 2r cosine theta. R squared is therefore 2x, and that means x squared plus y squared is 2x. So that's pretty straightforward. All right, we are going to bring the 2x to the left and put it next to x squared, and this 2 ax squared plus bx plus c. So this is b divided by 2 minus 2 divided by 2 is negative 1. Squared is positive 1. We're going to add 1 to both sides. So the left side is x minus 1 squared plus y squared equals 1. And that's an equation of a circle because reminding you x squared plus y squared equals r squared centered at 0, 0. X minus h squared plus y minus k squared equals r squared centered at h comma k. So it's a circle centered at 1 comma 0 with the radius square root of 1, which is 1. And so you locate the center, you go 1 to the right along the x-axis, or in this case, the polar axis. And because it's small, we're going to make two tick marks, one. So 1 and 2 corresponding to 1. So I'm explaining that here. And now you draw the circle and you're done. What about these two? We want to identify the graph and convert it accordingly. And when R is given, the technique would be to square it. And again, I'm reminding you of all of those. And remember, the polar grid is, with a bunch of circles, concentric. They have the same center and centered at 0, 0. And so R equals 4. We can square both sides and notice that this R is squared equals 16, and therefore x squared plus y squared equals 16. And as you know, this is a circle centered at 0, 0 with the radius square root of 16 over 4. So this is the point. That's the answer. Now, the point of this is it's a lot more efficient to use polar equation to represent a circle. R equals 4 versus x squared plus y squared equals 16. Theta equals 3 pi over 4. We're going to take a tangent of both sides, and tangent of 3 pi over 4 is equal to -1 because the same as pi over 4 in the second quadrant is negative. And when we do the cross product, we get y equals -x. As you know, y equals x is this way, y equals minus x is this way. So it's a line through the origin in this following manner. All right, so there are a bunch of theorems reminding you R equals a constant is a circle, center at the pole with the radius a. When theta is alpha, the line has the equation y equals tangent of alpha times x as far as the rectangular format is concerned. R sine theta equals a, that means y equals a is a horizontal line, and R cosine theta is a vertical line. R cosine theta equals a, it's x equals a. All of this represent the circle where R is 2a plus minus 2a cosine theta or plus minus 2a sine theta. All of them are circles with the radius equal to a. What about the center? For the cosine, is the center is along the x-axis, in this case positive, in this case on the negative side. For the sine is along the y-axis. So that's just the theorem that we know. Now, we want to graph R equals 1 minus cosine theta. And the best course of action is to just plot some pairs, and reminding you that R equals a times 1 plus minus cosine theta is a shape, heart shape is called cardioid. And so theta R equals 1 minus cosine theta and R theta. So let's go with easy, arcs and common arcs. For example, if I put 0 here, cosine is 1, so 1 minus 1 is 0. If I put pi over 6, 1 minus cosine of pi over 6, 1 minus square root of 3 over 2. Okay, pi over 4, 1 minus square root of 2 over 2. Pi over 3, okay, it's 1 minus 1 half, because cosine of pi over 3 is 1 half. 1 minus 1 half, which is 1 half. So if I go with pi over 2, we know cosine is 0, it's just 1. 2 pi over 3 is the same as pi over 3, but negative in the second quadrant. So 1 minus negative 1 half makes it 3 halves, and pi is -1. Minus 1 is plus 1. That gives you 2. Again, I went over this pretty fast. We've done this before, but just plug in. And here's the pairs, and we are going to look at the easy ones. For example, again, we're going to go with 2 tick marks to represent 1 because it's small. So 0, 0. As far as the pole is concerned, when R is 0, everybody, regardless of the value of theta, it represents a pole. So after that, we go to this one again. 1 minus square root of 3 over 2, you have to calculate it, and that is decimal square root of 2 over 2 is 1.4. It's about 1.7, 1 minus that. And so let's go with the easy ones, 1 half. So you locate pi over 3, and you go 1 half because we said 2 tick marks is 1, and then 1 tick mark is 1 half. So pi over 3 here. Pi over 2, 1. So pi over 2 is here. And 1 is 2 tick marks, 1 and 2, roughly. 2 pi over 3, so let's locate 2 pi over 3 is here. 2 pi over 3 is here. And we want to go 3 halves. That means 1 and a half. That means 3 tick marks. Okay. 1 and 2 and 3. Okay. 2 and pi. Pi is this one. 2 means 4 tick marks because so 1 and 2 and 3 and 4, roughly. And if you put them together, it looks like that. Also, we notice it's symmetric if we replace the theta with minus theta. Cosine of minus theta is equal to the cosine of theta. Nothing changes, which means it's symmetric with respect, WR2, the polar axis. So that means, just for the sake of argument, you can easily see that it looks something like that. Okay, of course, this is not to scale, doesn't look good. That's the idea, meaning if in the polar equation r theta can be replaced by r comma negative theta, resulting in an equivalent equation, the graph is symmetric with respect to the polar axis. And of course, you can pick up more pairs. Just as an example, 4 pi over 3 is the same as pi over 3, okay? And it's 1 half, but 4 pi 3 becomes negative, just like 2 pi over 3, and it gives you exactly the same answer, 3 halves here. 3 pi over 2 is the same as pi over 2, 0 gives you 1, so on and so forth. You can figure out the rest, and here's the complete graph, everybody. And the concept of symmetry can be seen, okay? Plot the complex number 1 plus I in the complex plane and write it in polar format. And they want us to do it in decrease, everybody. So having said that, let's remind everybody of what's going on. Number 1, Z is X plus YI or A plus BI. I hope you remember. R C theta is a shorthand notation for R cosine theta plus I sine theta, where R squared is the same as B for X squared plus Y squared. This is called the modulus or the magnitude of Z, or R or square root of X squared plus Y squared, and tan theta is Y over X. Very similar to what we have seen. And so when we look at a rectangular coordinate, the x-axis is the real part or the real line, and the y-axis the imaginary. So we go x amount to the right, y amount top. This would be x plus iy, and I hope you remember its complex conjugate is x minus iy. Okay, so that's how it works. Now, if I want to graph this one, and again, this is small, we're going to go with 2 tick marks. So 1 plus I, remember the coefficient of I is 1. So 1 plus 1I. So I'm going to go 1 to the right, 1 up, and I said I'm going to go with 2 tick marks. So no 2 tick marks equals 1. So 1, that means 2 tick marks to the right, 2 up. There you have it. And so you connect them, and now you calculate the R square root of X squared plus Y squared. That means 1 squared plus 1 squared, and it's square root of 2. Tan theta is y over x, and therefore it's equal to 45 degrees. Okay. So this is 45 degrees, everybody. So z equals 1 plus I is equal to r cis theta, and r is replaced with square root of 2, and theta is replaced with 45 degrees. shorthand notation would be square root of theta cis 45 degrees. Okay, that's a shorthand notation. Write the complex number 4 times cosine of 7 pi over 4 plus I sine of 7 pi over 4 in rectangular form. So that means just replace the 7 pi over 4. What is cosine of 7 pi over 4? Okay. First and foremost, 7 pi over 4, the reference arc is pi over 4. So whatever pi over 4 is. In this case, we are dealing with the fourth quadrant. Therefore, this is positive square root of 2 over 2. Sine is negative, negative square root of 2 over 2. And when you apply the 4, that goes away and it becomes 2 square root of 2 minus 2 square root of 2 I. Okay, so 7 pi over 4, this much. And the line goes this way. Theta is 7 pi over 4. And that's the point. That means if you look at this one, 2 times square root of 2 is about 1.4. So 2 times that is about 2.8. So 2.8 to the right, 2.8 down, just to give you an idea how you locate that. Find z times w and z over w and leave the answer in polar where z and w are given. Well, reminding you, when we have a polar format, this has been discussed already. Product of two numbers is R1, R2, cis theta 1 plus theta 2. Z1 over Z2 is R1 over R2 cis theta 1 minus theta 2. Therefore, if I want to multiply these two, I'm going to multiply their magnitude, their modulus, and then I'm going to add up. So I'm following that. I'm going to add up, okay, their arguments. So pi over 8 and pi over 10. So 2 times 2, and then cosine of pi over 8 plus pi over 10, sine of pi over 8 over pi over 10, and the common denominator for 8 and 10 is 40, divided by 8 is 5 pi, divided by 10 is 4 pi, and so we get 9 pi over 40, and we're done. Needless to say, 2 times 2 is 4. For z over w, we are going to divide them, and these two obviously cancel each other. Then we have cis, or just simply cosine of power 8 minus power 10, and plus I sine of power 8 minus power 10. And I hope you remember, over here it was 5 plus 4, now it's 5 minus 4. That means 1 pi over 40. So cosine of power 40 plus I sine of power 40. Or you can write, for example, cis power 4. That's another way of writing the same thing. Again, that's a shorthand notation, everybody. We want to write this in the standard form. This is going to be raised to the power of 6. Well, we use the Moir's theorem. So in addition to product and quotient, the Moir's theorem says when n is larger than or equal to 1, z equals r cis theta. When we want to raise it to the power of n, we raise the r to the power of n, and we multiply the argument theta by n. So with that being the case, if we want z to the power of 6, we're going to raise this one to the power of 6, and we're going to multiply those by number 6. So with that being the case, I hope you realize this one becomes 3 cubed, right? Because it's square root of 3. And then 6 times 5 pi over 18. Let's just do the simplification. What color can I use here? Let's go with this. 6 goes away, 18 becomes 3. So 3 cubed is 27. And as you know, cosine of 5 pi over 3 is the same as cosine of pi over 3. The reference arc, everybody, is pi over 3, in other words. So I can change this to pi over 3, and this becomes negative and pi over 3 because for cosine of 5 pi over 3 is the same as pi over 3 is positive in the fourth quadrant, but sine in the fourth quadrant is negative. Now, what is cosine of pi over 3? 1/2. What is sine of pi over 3? Square root of 3 over 2. So this is 27 halves minus 27 square root of 3 halves pi. This is the standard form. Given z equals 8, find the complex cube roots. Again, we have various formulas here, and I'm going to remind you, if W is R cis theta sub 0, for n larger than or equal to 2, there are n distinct complex nth roots of W. Z sub k is the nth root of R cis theta sub 0 over n plus 2k pi over n. You can go with radian, or in this case, 360 degrees k over n. You're going with degrees here. And the value of k is 0, 1, all the way to n minus 1. Okay, so first and foremost, W equals 8 cis 0. Okay, in this case, that's the reason I'm calling it W, because I want to go with that. Okay. By the way, just quick reminder, class. Remember, this way is a 0 degree, right? So if you have a positive number, any number that is positive along the x-axis, for example, positive 5, that would be 5 cis 0. But if you have negative 5, it's 5 cis pi in general. So any number that is just real, okay? The modulus or magnitude is the number, and the angle that it has, it's either 0 along the positive side or pi along the negative side. So if it's positive, 0. If it's negative, pi, or 180 degrees. I'm going to erase my work. And so with that being the case, we are going to go with this, and we say the nth root of R cis theta 0 over n plus 2k pi over n, and we're going to go with, what do we want, cube root. The third root of 8 theta sub 0, as we said, is 0, and then 2k pi over 3, and you can go with degrees or radians. I put the degrees here, I put the radians here. It makes no difference whatsoever. Of course, this is 0, and this is 2, so we get 2 cis 2k pi over 3. And we can use 0, 1, 2, not 3. If you use 3, just right away, I want you to recognize. If you put 3 here, 3 cancels out the 3, and you get 2 pi, which means you go back, you go around the circle one complete revolution, and you are going to repeat what you did with 0. So having said that, let's plug in 0. We get 2 cis 0. Let's plug in 1. We get 2 cis 2 pi over 3. Let's plug in 2. We get 2 cis 4 pi over 3. So as I mentioned, if you go with 3, you get 2 cis, 2 cis, and this cancels 2 pi. And 2 cis 2 pi is the same as 2 cis 0. That's why it goes back. So starting with the 0, I hope you know cosine. Cosine is 1, sine is 0, so it's simply 2. The second one, 2 pi over 3 is pi over 3 is the reference arc, so it's the same as pi over 3 in the second quadrant. Cosine is negative, so this is negative 1/2, and this is positive square root of 3 over 2. Multiplied by 2, you get negative 1 plus I square root of 3. And the last one, 4 pi over 3, again, the reference arc is the same as 2 pi over 3, which is pi over 3. So it's the same answer, except what happens is that in The third quadrant, not only cosine, also the sine. Both of them are negative. So this is negative 1/2. This one is not square root of 3 over 2, is negative square root of 3. So both of them are negative. So it becomes negative as well as this. Y, again, 4 pi over 3. Vector V has initial point P and terminal point Q. Write in the form of AI plus J. Find its position vector. Also find its magnitude. This is the magnitude where P is given as 3, 2. Q is given as 5, 6. So let's remind everybody of what's going on here. So this one, P has coordinates A comma P as this is the initial side, this is the terminal side. Initial side, terminal side. So a few things we want to discuss. Number one, position vector. If V with components A, B is an algebraic vector whose initial point is at the origin, then V is called a position vector. So what is a position vector? The initial point must be at the origin. Algebraic vectors, V is AI plus BJ or A comma B, and A and B are called components of vector V. So what else? A vector with initial and terminal points x sub 1 and y sub 1, and terminal points is x sub 2, q sub 2, is equal to position vector V is PQ, x sub 2 minus x sub 1, y sub 2 minus y sub 1. So with that being the case, we are going to use that and say x sub 2 minus x sub 1. That means 5 minus 3. Y sub 2 minus y sub 1, 6 minus 2. And this is 2, this is 4. So those are the components. Or we can write it as 5 minus 3 times I, 6 minus 2 times j. In other words, 2i plus 4j. So there are two ways to represent the components. So we got that in this format as well as this format. That is the position vector, if you will. And what are they asking us to do is to come up with the magnitude. So what is the magnitude? The magnitude is any vector is square root of a squared plus b squared. In other words, components square them. If the magnitude is always larger than or equal to 0, if it's 0, then the vector must be a 0 vector. This 0 is 0 vector. And the magnitude of two opposite, vectors that are opposite of each other is the same. And the magnitude of A times V is the absolute value of A times the magnitude of V. So having said that, we're going to go with this formula. And we are going to put in there 2 squared and 4 squared. And we get 20. As you know, 20 is 4 times 5. 4 comes out as 2. So we get 2 squared of 5. So a quick recap for vectors. Two vectors are considered identical as long as they have the same direction and they have the same magnitude. It's called a position vector if the initial value starts here. And of course, the magnitude is square root of a squared plus b squared. To make it a position vector, we go with this formula. A vector PQ is x sub 2 minus x sub 1. That is a component along the x-axis, and y2 minus y1 along the y-axis. Now, given the v and w, we want to find the magnitude of v plus w and 2v minus 3w. So starting with the magnitude, a squared plus b squared minus 2 quantity squared plus 3 squared under the radical. This is 4, this is 9. We get square root of 13. V plus W, so just add them up, and to add them up, just add up the components, meaning this one and this one. They add up to 3I. These two add up to minus j, and you're done. 2v minus 3w, so 2 times v plus 3 times w. Just write it down and distribute. So this is minus 4i plus 6j, minus 15i plus 12j. This to add up to negative 19i. And we have 18j, and that's the final answer. Find the magnitude, direction, angle, and a unit vector in the same direction for the following vector v equals 3i plus 3j. So speaking of the magnitude, let's quickly calculate it as 3 squared plus 3 squared, 9 and 9 is 18. Square root of 18 is 3 square root of 2 because this is 9 times 2, 9 comes out and 2 remains. As far as the direction angle is concerned, tan alpha is b over a. So reminding you, any vector is the product of its magnitude and cosine alpha I plus sine alpha j. Direction angle alpha is between 0 and 360, and it is the angle that is made between the vector and the I. That means the positive side of the x-axis. And so tan alpha is b over a, which makes it 3 over 3, and it's 1. And of course, that is just 45 degrees or power. So we have the magnitude, we have the direction angle. And so we are going to put it in this format, everybody. This is replaced with 3 square root of 2, and alpha is replaced with 45 degrees. Unit vector in the same direction. Unit vector in the direction of v, we call it u, is the vector v divided by its magnitude. So all you have to do, divide this by its magnitude, which means we are along the x-axis, the I, so v equals AB, the component A times 1 comma 0 plus B times 0 comma 1 is AI plus BJ. I is the unit vector along the x-axis. J is the unit vector along the y-axis. So we are going to divide this one by 3 square root of 2. And of course, 1, and I hope you know that 1 over square root of 2. We can multiply by square root of 2 over square root of 2, and we get square root of 2 over 2. It's the same as square root of 2 over 2. And this is the unit vector along in the same direction. And if you want to prove that, all you have to do, just square this one, they have to add up to 1. The square root of 1 is 1. A plane is flying at a speed of 200 miles per hour on a bearing of north 55 degrees east. The wind is blowing from west to east at 35 miles per hour. Approximate the ground speed of the plane to the nearest miles per hour, and the true course of the plane to the nearest tenth of a degree. So northeast. So you make a north 55 degrees east. So that's the direction. So if this is 55 degrees, then this must be 90 minus 55 degrees or 35 degrees. So this v sub a, that means the velocity with respect to air, has the magnitude of 200 miles per hour. And we want this angle, everybody. This angle is 90 minus 55 or 35 degrees because in this format, this alpha represents the angle that it makes with the positive side of the x-axis or I. The wind goes from west to east, goes this way, which is parallel to this line, which means the magnitude is 35 miles per hour, but the angle it makes is 0 degrees. So this is our draw. Approximate the ground speed. The ground speed, we have to add these two vectors. Now this, and we want to come up with the true course. First and foremost, this makes an angle of, we got to call it alpha with respect to the positive side of the x-axis. Okay. This is v sub g, the velocity with respect to the ground. So the ground speed is this magnitude of v, miles per hour. And the true course, everybody, is northeast. But this angle is what? 90 minus alpha. So one more time, the green line, we want to find the true course is northeast. What is the angle in between? We don't know. But if we can find alpha, we subtract from 90, we have the answer, and we can find alpha. So to do so, we are going to add these two. So we're going to write the components for each one. V sub A is 200 cosine of 35i plus sine of 35j. 35 degrees is not a common arc. You put it into a calculator, you come up with this answer. The wind, 35 cosine of 0 degrees I plus sine of 0 degrees j. And as you know, cosine is 1, sine is 0, so simply 35i. So if I want to add them up, simply add up the components. That means add up these two. And the other one doesn't have any components. So it's 198.83i plus 114.72j. We can find the magnitude, square root of a squared plus b squared, which means square this one, add them up, put it into a calculator, and that gives you about 230 miles per hour. Then to find the alpha, tan of alpha is this component over the, tan of alpha is b over a. And alpha, you use a calculator, you end up with 29.98, let's say 30 degrees. Of course, you always round accordingly. And so the true course, if alpha is 30 degrees, that would be north. 90 minus 30, that makes it 60 degrees east. And the speed is 230 miles per hour.